Hola. Today we're going to cover the first subtopic of the third topic, thermal physics, called Simple Kinetic Molecular Model of Matter. State the distinguishing properties of solids, liquids, and gases. Solids have a definite shape and volume. Liquids have no definite shape and a fixed volume, which allows it to instead take the shape of its container. Solids and liquids are incompressible. It cannot be squashed because there are no gaps between the particles in them. Gases have no definite shape or volume because there are large gaps between the particles, making them compressible and enabling gases to change size and shape. It expands to fill its container and takes the shape of its container. Liquids can actually be compressed, thus volume can decrease, but volume decrease is considered negligible. This is just an extra fact that you may find interesting. Properties and molecular structure of solids, liquids, and gases. For solids have very strong intermolecular forces of attraction. That's the forces between particles. This causes their molecules to be tightly bound. Solids have the smallest distance between molecules. They are also arranged regularly, or in other words, arranged in a lattice, as this minimizes the distance between particles. You probably learned this in chemistry. The strong forces of attraction prevents the molecules from moving, so they instead vibrate around a fixed point. Liquids. Liquids have a moderately strong intermolecular force of attraction. This means that the molecules are held close together, but not so tightly that they can't move. This allows liquids to rotate and flow over one another. Due to the movement of molecules in a liquid, the molecules in a liquid are constantly in motion, even if the liquid as a whole is stationary. The arrangement of molecules in the liquid is irregular. The intermolecular forces of attraction in liquids are not as strong as the forces in solids, so the molecules are usually further apart. Gas. Gas has a random arrangement, just like liquids. Gas molecules have so much kinetic energy that they are free to move in any direction, and the molecules are very far apart. The kinetic energy of molecules overcome any forces of attraction, making those forces negligible. The movement of gas molecules also mean that they tend to fill out their container, taking its shape. As gas molecules are very far apart, they can be compressed, forcing the molecules closer together. This expansion of gases to fill out its container and the ability to compress gases mean that the volume of gases is not fixed. Pressure of a gas and the temps of states of matter. When a higher pressure is exerted on the gas molecules gain kinetic energy, causing them to move faster and more erratically due to more collisions. There's a video here by freesciencelessons.org who covers more of this movement of gas particles and the pressure it may cause. Okay, we're going to talk about the shifts or the states of matter and how they come to be, like what processes are needed for them to shift from like gas to liquid, liquid to solid, stuff like that. So a solid becomes a solid is a solid, like I said, because the particles are very close together. And the forces are stronger. The thing is, what you need to do to make it a liquid and eventually a gas is you have to transfer energy to the particles, and then the particles will have kinetic energy and they'll move around more. And they'll try to overcome the forces holding them together, the intermolecular forces. And if you transfer enough energy and the particles gain enough kinetic energy, it moves to a liquid phase. Same thing applies if you apply more energy and more kinetic energy of the particles have more kinetic energy, then it will turn into a gas once it reaches a certain temperature, depending on the material. Now, the opposite, where it's like from gas, from the particles being very far apart to a solid, to like very close together, you need to cool. So the energy, the kinetic energy of the particles, it has to decrease, and maybe it just goes elsewhere or something like that, or they lose energy. Yeah, they lose energy because it goes elsewhere. This energy is constant. Like, I mean, energy is not, it's not really constant. It's more like it, you can't delete energy. It's just transferred or converted. So yeah, to cool, there's a loss of energy, and the particles um, uh, go closer together, and then the forces have a more significant effect. And eventually, as it keeps cooling and cooling, energy decreases. It becomes a solid. Kinetic energy of a gas makes particles move apart, and forces are negligible. Liquids have weaker forces and higher temps, and solids have very strong forces and lower temp than liquids. So gas pressure, motion, and collision and pressure changes can be seen by, can be learned. Gas pressure, motion, and collision and pressure changes. You can learn these from MrFreeScienceLessons.org. He explains it much better than me. And here's his video. I'll put the link up above in the eye clicky thing. Watch it and then do the questions and then come back. Brownian motion. Particles in both liquids and gases, collectively called fluids, move randomly. This is called Brownian motion. They do this because they are bombarded by the other moving particles in the fluid. Larger particles can be moved by light, fast-moving molecules. So this is an experiment I did. You can play around with this website here. That. But basically, my findings have shown that when you have smaller particles, there are three things that can affect the movement of larger particles. First, an energy increase. When you increase energy, the molecules increase in speed. Larger particles, because the smaller particles gain more kinetic energy and they collide more. And then when you increase the size ratio, the molecules increase in size and the smaller ones, and there's less space for the particles to move. So the movement decreases. It's like a solid. When the mass ratio increases, the particles move faster, shown by the movement trace paths, but not as much as an increase in energy, I think. It's probably because the motion of the massive particles increases because the weight of the smaller particles is more, and so these particles inflict more force on the bigger particles. More energy is transferred when the smaller particles hit the bigger particles. And for the energy part, I'm gonna say more stuff to explain it. If there's more thermal energy most likely. The light molecules move faster, which causes the massive particles to move more as more collisions take place. And of course, the thermal energy is converted to kinetic energy. Describe melting and boiling in terms of energy input. So melting, boiling, these are points that the thing that you are heating or cooling doesn't change temp. This happens because the energy is trying to break apart the particles from the bonds, like they're trying to move them away. And you have, it's just at that point that the temperature does not change. At that point, the bonds are being, the latent heat is causing the particles to make their bonds less significant. It's for the whole, it's for everything that is being heated. So at this point, temperature does not change. Only after that does it become a liquid or solid. Melting and boiling point meaning. Melting point or freezing point equals temperature when solid becomes liquid or is in the process of becoming liquid, or when liquid is in the process of becoming solid. Boiling point or condensation equals temp when liquid is becoming gas or when gas is becoming liquid. It's in the process of, but it's not yet there. Condensation versus solidification. Condensation is when a gas changes to a liquid. A gas loses heat energy. They also lose kinetic energy, causing them to move slower. Their intermolecular forces of attraction become more significant, pulling the molecules together and allowing them to form weak bonds until they form a liquid. Solidification or freezing is when a liquid changes to a solid. As liquids lose energy, their molecules slow down and form more intermolecular bonds with one another. They become locked in place and thus they form a solid. Boiling versus evaporation. Boiling and evaporation both refer to a change in state from liquid to gas. However, boiling occurs at a fixed temp and happens throughout the liquid. Evaporation can occur at any temperature and happens from the surface of the liquid. Evaporation and its effect. Evaporation is the escape of more energetic molecules from the surface of a liquid. When these energetic molecules escape, the temperature of liquid it has escaped from decreases because this high energy molecule obviously had to have a lot of kinetic energy to escape. So by it escaping, it has decreased the average kinetic energy of the particles in this liquid. Factors that affect evaporation. Increasing temperature of the liquid through energy transfers of most likely heat energy obviously increases the rate of evaporation. As more energy is transferred and average kinetic energy increases, so do the number of high energy particles out there that will eventually displace the particles on the surface that have already evaporated and then evaporate themselves. It just quickens stuff up. Wind moving over a water or land surface can also carry away water vapor, essentially drying the air, which leads to increased evaporation rates. So sunny, hot, dry, windy conditions produce higher evaporation rates. An increase in surface area allows the particles at the surface to give more access to energy sources for energy transfer and means that more particles are exposed to air. And you know what air does, right? These are my sources.